Problem 15, threeSum. Okay, have to be careful with the pronunciation of the name of this problem so that you don't accidentally say something inappropriate. We are given an integer array of numbers called nums. Yeah, that's the name of the array. And we need to return an array of triplets, an array of all the triplets that sum up to 0. Okay, so all of the triplets must have, all of the numbers within triplets must have different indices. So you can return one number twice inside a triplet, but only if you actually have two copies of this number, like you have in this input here, right? So basically all of the indices within a triplet must be different, and plus all of the triplets must be different, right? All of the triplets. But now here we not only mean indices, I think, but we mean actually values as well. Okay, so for example, if here we had a third -1, we already have 2 -1s in the input array. Even if we had third -1, we could not return another copy of this array, of this triplet, and claim that, well, that's in the second option, in the second triplet, it's a different -1. Well, can't make that claim because the triplets, in terms of their values, must be different. But within the triplets, I think what they mean is within the triplets, you can repeat numbers, but as long as they actually match elements with different indices in the input array. Okay? So all of these are important details that we need to remember. Because, for example, I mean, this thing that we cannot repeat, we cannot duplicate triplets, that's going to have a considerable impact on our solution, a large impact. Because, for example, if we didn't have that, then we could not hope to find a better solution than O(n) cubed, because indeed we could have all zeros in the input array, and then every triplet would work, right? Every triplet would work, just as an example. And if you have that many O(n) cube, order of n cube solutions, then your algorithm should have at least that time complexity, because how can you then even return or touch these separate triplets if you don't have that many operations? Yeah. But because we have this constraint that we cannot return, or we should not return, duplicate triplets, we can hope to improve the time complexity here. Now, I will claim that we cannot improve it better than O(n) squared. Yeah, that will be my claim. So we shouldn't even try to do better than O(n) squared. Why? Because I think you can easily imagine an input, let's say starting from some -k plus 1, and so on, -1, 0, +1, so on, k minus 1, and k. So just sequential numbers from -k to +k. And you can easily prove, I won't trouble you with this, that in here, the number of triplets that sum up to 0 would be order of magnitude of k squared. Yeah, there will be some coefficient, divided by 3, blah, blah, something. I mean, it doesn't matter. We don't have to do the actual precise computation of this, but you will see that it will be k squared, which is the same as O(n) squared, because k is kind of roughly half of all of the elements here. So we're going to be looking for an algorithm that is O(n) squared time complexity. And for memory complexity, we'll see. Probably what we'll do is the memory space complexity will be, I mean, we will need another array of some sort of, let's say, O(n), because we just simply need to return this array of triplets. Now, first of all, because we know that we're going to be doing something at least O(n) squared, we can easily sort this array without any guilt, right? We can say we can just sort this array in a non-descending order, okay? And I think I already did this in here, right? Yeah, whatever I have on screen is, let's say this is after sorting. So we've sorted it. This is going to be helpful. I think we can feel it, that sorting this array will be very helpful. So, and since we're working on O(n) squared again, why don't I just fix temporarily this value, call it the first element of the triplet, and within the rest of the array, what I'm going to try to do is, in O(n) time, can I find all of the doubles, all of the pairs of numbers, which can be grouped with this first number to produce a triplet that sum up to a 0, right? So if this is -5, then I could say, well, how about finding two numbers that add up to +5 in this suffix of the array, right? And if I can do this within O(n), then I'm going to be happy, right? I'm going to achieve my goal. So in terms of, should we just write this first part? So assume that we somehow have the solution for this whatever I just described in terms of finding within O(n) time complexity, finding all of the pairs that add up to some target, right? All of those pairs, and returning them, let's say, one by one. So I'll write a generator function for that. Let's actually start writing this a little bit. So you know what? I'm not going to write here. I am going to move to typescriptlang.org, yeah, because the editor here is slightly better. Okay, so I will have a generator function, like a helper function that calls that, let's call it getPairs, right? Now, what should it take? It should take all of these numbers, right? And an offset, right? Let's say start. Also, well, target, first of all. It should take a target. The sum, right? Target sum. Let's call it a sum. And it should basically return pairs that sum to this sum. And also the start. That will be the offset, right? I mean, you could say that defaults to 0, but I don't think that will be in any way helpful. So, and this should be a generator function, which should yield a pair of number, right? So I'm hoping that you're familiar with the generator functions. So that's kind of a function that can have multiple returns. Although we don't call them returns, we call them yields. And then it can actually return the final value as well. But I'm not going to actually go into the details how these things work. So it will have multiple yields. It will yield this tuple potentially many times, maybe 0, but potentially multiple times. And then it will finally return void. And also, when I say resume, continue, next, whatever, I'm going to pass nothing. I'm going to pass void back into the generator. Okay? So let's assume we have that sort of function already written, that sort of generator function. And with that in mind, I mean, we're going to write this later, and it must be, this one must be O(n). How are we going to write our solution if we had this function, right? So, well, we said this already, right? So initially we're going to start from the first thing, right? So first we would need triplets, where we're going to collect our triplets. So that would be this, yeah. Or we could say this is number. Maybe that's more precise. And eventually we're going to return these triplets, right? So why did I say not number? It's triplets, right? Okay, so that. And to be quite honest with you, I think this signature also is better here. That's more consistent with what the problem asks. Now, if we have that, right, notice what we're going to do. So let's start with, we said first equals, this is the index, right? First equals 0. And then first must be less than num's length minus 2, I guess, right? Because minus 1 would be the last element. Minus 2 would be the penultimate element. But in terms of first of the 3 should be even lower than that. It cannot be num length minus 2, because then you would have only one element left. You need at least 2 left to create a triplet. So the last value for first would be num's length minus 3. That gives you 2 more elements in the array to find at least one more pair. And what? Plus first. Plus first? Really? Well, yeah, not really. Because here is why. Remember they said don't return the same triplets multiple times. So this is sorted in ascending order, right? So if this value repeats, when we are done with this minus 5, let's say we already collected all of those triplets that start with minus 5, and from the rest we found everything. Now, when you move here, and if it's the same number, minus 5, then there is no point in rerunning this, because now you have the same first number, the same target of plus 5, but the suffix is actually smaller, where you can search for the pairs. So anything you're going to find here, you have already found in the longer suffix. So there is no need of rerunning this. If you find anything, this is already present. So with that, if we do that, we're going to ensure that every triplet will have, every time we run this, or every time we will have different, first element will be different, right? So that means if we also make sure that this generator never returns the same pairs, right? For within one call. So within one target, when we give it one target, one sum, it should never return the same pair twice. Then we don't have to check anything in terms of whether we are doing duplicates or not. That will be very efficient, okay? I think you understand why. Okay, so I have to ensure that I skip in my loop when I do first. Once I come here, I have to instantly go to the next value. How do I ensure that? For that, let's say, why don't I just say last value and just initialize it to some nonsense, something that definitely is not going to be inside this array nums. And I'll say, well, this is the value that I've seen already, okay? And the first thing I'm going to do here is if nums first, you know what, I'm going to do it this way. If last value equals nums first, then what? Then I'm gonna continue, continue, right? Otherwise, what I'm gonna do is, thank you very much. What I'm gonna do is actually make last equal to nums first. Okay. So if I continue, that means we go to the next first. And if I say last equals nums first, that means we're going to go down here, right? So every time we are allowed past this line, past line 6, that means last equals nums first, okay? And this is going to be the only time we're going to come in with that value, right? Because if nums first repeats, last will not allow us past this point. So we're going to look at each value only once. So first, right, will get us past this line only once for each value. Now here, what we can do is, let's use this function that we have, right? For run through each pair of getPairs, nums, and sum would be minus nums first. Well, let's do minus last, right? Because last is the same as nums first. So minus last, that's the sum that we want. And start would be first plus 1, right? Starting from first plus 1. And plus 1 because we cannot repeat indices. So we should start from the next index. Okay. So that loop will cycle us through different values that will be yielded from this generator function. Right? So this generator function, every time we yield something, right? Yield some sort of pair, right? We will get this pair inside this variable, and then this function will be temporarily suspended until we call it again, but this will be done for us within this, with this for loop, right? With this syntax, with this of syntax, basically. So this is a very nice use of this generator utility, generator thing that we have in TypeScript, JavaScript. And because these are going to be different pairs for this target, now we can each time simply push into triplets first of all, last. This is the this will be the actual first. So last means the last first that we've used, but this is actually the value of the first element in the triplet. And then each element of a pair, right? So we're going to push this. This is our triplet now, right? Because this is the pair. And we're going to kind of take them apart with this ... And last is obviously the first element of the triplet. Now, why it's in the last? Because last means we don't want to repeat the first element. That's why we already talked about it. So that is pretty much everything. Yeah, that's a very... Oh, it's not pretty much everything. We have to write this function. So let me collapse the main function, get rid of this stuff. And we need to write this generator here, right? Okay. So now let's focus on that generator thingy. Remember, it has to work in ON. It takes a sorted array. Did I mention somewhere that this sorted nums, this should be sorted, yeah, and it should be read-only, and it's sorted nums, right? So read-only means we're not going to modify this. Okay. So what I'm going to do here is basically we will have a starting point pointing somewhere, and it's a sorted array. We gotta find two numbers that add to sum and return them one by one. Oh, sorry, all of these pairs within ON. Now, because this is sorted, why don't we start with left pointing at the beginning and right pointing at the end? And what should we do? So calculate the sum of these two, so -4 and 9, right? So if that sum, let's say if it's above what we need, then we will move this to the right, to the left, sorry. If the sum is below the target sum, then we'll move the left point to the right, yeah, to the next element here. And if it's exactly the same as sum, then we will yield that pair. Yield means kind of return it, but also pause temporarily the function. We will yield that pair, but what should we do with indices? I think we can increase both left. We can move both left in this direction and right in this direction. And the reason we can change both indices is because well, here we also have to remember that, if we've returned some pair, we shouldn't return this pair twice, right? So why don't I actually also remember the last left value that I've returned? Okay. So the last left value that I returned, I will remember that. So left value, right? And I'll have a variable called last where I will keep that value, the last one that I've already returned. So if these indices both add up to the required sum, then if the left is different, I'll yield that pair. Then I'll update last to equal to this left value. And now I can actually move both of these indices. Why? Because if, say, for example, this -1 was returned, there is no point in trying this -1 again. I can go that way. But also this number. So if the sum has to stay the same, right? We've just found that sum. Then obviously we have to change at least one number. But if sum stays the same, changing one number is not an option. The second number cannot stay the same. The second number must also change. So that's why I can do that. Now, when I come back into the loop, I might find that at least one of the numbers has stayed the same, or both have stayed the same. It could be, but that's not a problem. At least I know that none of those indices are going to be useful to me again ever. So I can nudge both of these indices in the correct direction. And then once I come back, this last value will protect me from repeating the same, from yielding the same value again. So let's write that. So how should we do that? We will, okay, I'm going to do a while probably, right? So let left be start, right be sorted nums length -1. Let last value, last left that will return, yeah, last left, let's call it last left, equal to what? We haven't really returned anything, so let's set it to something that, you know, -infinity, anything that we know that's not going to be actually a candidate value to be returned in our pair. Now I can do while left is less than right. Now why strictly less? Because we cannot repeat indices. So if, let's first calculate candidate sum, right? So sum of these two would be sorted numbers left plus sorted numbers right. That's our S. If this sum is actually less than the target sum, then what should happen? So we are less than that. We should increment left. Else, if S is already over the sum, we should decrement right. Okay? Yeah, because if we're over the sum, then we should decrement the higher end of the so we should decrement this. We should do this. And else, what else means, then we got the correct sum now. It's neither over nor under the target sum. So we are looking at the correct sum. So here we should see we're going to be yielding basically. We're going to be yielding this pair called nums, sorted nums left and sorted nums right. We're going to be yielding this. But before we yield it, we should check whether we've already returned this. So, and we'll do this by saying by last left, if last left not equal to sorted nums left, then we can yield it. But before we yield it, why don't we, what did I mean to do here? Why don't we say last left equals sorted nums left? Yeah? Because if it's different, we're going to return it, but we need to remember that we've returned it, right? And I usually always follow, when this check fails, I usually instantly follow it with this response. Now, outside of this if, I need plus plus left minus minus right. So this should happen whether we return this pair or we say, oh, we've already just returned it previously. Does not matter whether we've already returned or not. We're never going to look at these indices ever again. They're not going to be useful ever again. Okay? So this is done. Should we try this? Console log. Now let's try this. Console log threeSum on this. Console clear maybe. Run. And nothing. Why? Why nothing? So we get absolutely nothing. So getPairs, what is going on? So maybe let's try getPairs. If we were to do for, let's say, pair of getPairs, let's say from this and then we need sum. Let's say the sum is 0 and start is also 0. And here we will have console log the pair. No, nothing. Okay, so getPairs isn't working. Why are you not working? While left is start, right is sorted nums length -1, last left, left is less than right. This is the sum of those two. And then if it's not equal to the previous one, we're going to make it equal and we're going to yield it. Why are not we yielding it? Why don't we say here console log left right? So we're looking at 1, 5, and our target sum is 0. So when we look at 1, 5, 1, 5, why 1, 5? My console log is right here. And left is start. And this is length -1. So 1, 2, 3, 4, 5, 6. So right is correct, but left is 1. How come is it 1? Because I said start is 0. So 1, 2, 3, 4, 2, 3, 4, 3, 4. That's nonsense. What is going on here? 1, 2, 3, 4. And so basically this is not even nudging. And then we got empty. Am I doing console clear somewhere? Yes. What is going on? So I expect this to say 0, 5, not 1, 5. And sum would be S. So sum here, oh, because this is not sorted. Did I not sort it? Oh, I didn't sort the array. Okay, that is quite nasty, stupid mistake. So I didn't sort the array. I have to sort the array nums, right? Let's sort it in place. So nums, sort, and so let's say A minus B. And you know what? Since I forgot it, why don't we do ascending equals that? But we need typing here, number. We would not need typing if we were just using this inside sort, because typing would be inferred. So get rid of all of those console logs. Right, don't need this. And don't need this. Just run. Yeah, we got the reply. That's correct. That is precisely correct. Okay. Now we can take these functions, move them into here. You know what? Let's collapse them because that looks, these are too big. Okay, try them on the pretests. Okay, that was fine. And now on the actual tests, see what happens. See what happens. Accept it. Okay, we only beat 23%, not that many. 23%. Okay. And in terms of memory, we beat 6%, right? 6%? What the heck are we doing here? So the generator isn't a heavy structure in terms of memory load. We are only using the memory that we need to return. I mean, and then some constant memory. Okay, so this bit is definitely surprising. Definitely surprising. In terms of this bit, okay.